Hey guys, this is Coach Partha from Varanashi Farms. I want to talk to you about some mapping, right? I found this book. This is made in 1940s, the mapping of our farm. Um, yeah, really old. It's like 60 years old. However, in the modern days, there is GIS or Geographical Information System. We have the satellites up there taking images, and the coordinates are calculated or found out using these GPS machines. Now, the farm has been curated by my parents over the last 35 years. It's fully organic. It has different plots. It has different irrigation layers. It has different tanks at different altitude, and the pipelines go everywhere. We have all different types of varieties of crops growing in different levels of these farms. So when you have the mapping, it gives us not only accurate information, but also the management of the farm is could be done much more efficiently, and we can do the day-to-day activities of the farm much more smoother. So it's just that gives that farmer the power to have that control, and also to know what's happening in his farm, right? Today we have two experts from Switzerland. One is an expert in the mapping sector. They use something called QGIS, QGIS. It's a software available out there, and another expert in hydrology, so in water systems. Okay, I'm going to quickly introduce you to them, and they will talk to you about how this mapping is done, and also how we can use it for our irrigation system, and also the other benefits of it. All right, guys, we have Armel here. She's an expert in the mapping. She's got a lot of experience in this field. I'd let Armel talk about it. Armel?
So hi, so I'm Armel. I am from Switzerland, and I've come here with my husband to discover a bit about sustainability in India. And so I have a bachelor in geology and environmental sciences, and then a master in biogeosciences. I worked mostly in the public administration on sustainability.
Nice one.
So basically, Marc and I, we had a project to map the whole farm, and the main advantage is to have everything in one place. So before, as you saw, it was in a notebook, so it's handwritten, and you can lose it like easily. It can burn, or you can, I don't know. Yeah. So with one map, you can have everything. It's easy to read. You will have all the names, all the crop. You will have each plot separated from another, so you could understand like the surface of the plot and what's growing where. So we mapped the plot, we mapped the water network, and we mapped all the buildings, the road and the path in the farm. So for that we used QGIS. Can you show? So QGIS is an open source and free software when you can import your data. We used just simple GPS. So we walked around the farm in each road, each path, and around every plot, sorry. And so at the end we could obtain a map of the situation. So can you zoom in? Around here maybe? Yeah. So you see every building. This is the volunteers pond, which is going to be filled soon maybe. This is where we stay, and this is the road, and this is every farming area with a pond that are used for water irrigation. Can you open the attribute table? So the map is linked to a table of attributes, and you will have every information for every field. So this one is selected, and you will have what's growing inside, and you will have the name of the plot. So basically all information in one pond. It's interactive, so you can just go around and just explore the map like that. It's not that difficult to understand. Maybe it's a bit difficult to grasp, how to make it, but once you have it, you can edit it quite easily. Can you what else? So now we have all the basic information on the field. Marc will talk about the water network. Just to talk about perspectives, if we could include also the productivity per plot, we could have a follow-up of the situation, like what kind of money you put in each plot and what kind of production you get from it. So you could really have a monitoring of your situation, and adding the financial aspect would be quite good. So just for now, I'm going to let Marc speak about water. So you can also map the water network and even create a concept based on simulation.
So guys, we have Marc here. He's a hydraulic engineer and has also worked in this field for quite a few years in Switzerland. And I'd want Marc to tell us about himself and then also explain what he has done at the farm. Marc?
So hello. So I study in Polytechnic School in Lausanne in Switzerland, where I study environmental science and engineering. After my diploma, I worked 5 years in the office where I got specialized really into urban hydraulic and for water network and evacuating water into the cities. After this, with my wife, we decided to travel a little bit and discovering your beautiful country, India. So when we arrived in Varanashi, we saw the situation and we suggest that we could maybe do the mapping and propose a new concept for the water irrigation. But first of all, so about irrigation, we see now a tendency of having longer droughts and with high intensity rain. That will be in the future more and more common. That means it's really, really important to improve the irrigation network and the water distribution. To improve it, that means you need to have a good sources, so bore well or just different sources. That's the first thing. Then the second thing is to store it. To store it, you have a tank or like this, a kere, a pond. And once you have this pond, it's just pipes which going down up to the point where you need water. So it could be for irrigation, could be also for drinking water or domestic use. I will now explain a little bit how this is done for Varanashi Farm, explaining what was the actual situation and what we propose for the concept. So in Varanashi Farm, they had already a really good system with a bit too much complexity, too much pipes. There's like pipes everywhere. You can see all the lines here. That's all the pipes connected. Here's the pond, and we have also here the bow well. So each time is written on this map the name of the bow well, the flow, the water flow of this bow well. So we have a pump into the bow well which can produce up to 200 liters per minute. Then this bow well will pump it here, up here, to this tank. It's a 1000 liter capacity tank at 110 meters above sea level. This one will distribute water to the food court and here down to the dome. But it will also give water to this fun pond into all the system below. Once this pump is shut down, we can use the water here, and then you see all the different pipes and go down. That's the basic idea. Maybe now I can show you a synoptic plan. So this plan is just to understand a bit better where the gravity of the system is given. So as I told you, it's like always, first thing is to look for the sources and then to the tank, which should be the highest point of your system, and then underneath the tanks should be all the distribution plot. So here we have the 3 bore wells, the main sources of the farm. Then here the tank, and also the different ponds. And then the black thing is where the water should be reaching. Now that I had like a really good situation with the height here, so the highest point is the campsite kere and also the food court tank. I was wondering, why should we need 1, 2, 3, 4, 5, 6 and like 10 more here? Like more than 20 tanks are constructed for Varanashi Farm. You don't need this. You could do it much simpler. You could just have like one big tank at 110 meter, which give the water for everyone. So you will reduce it, the number of pipes, the number of tanks, and so you will save also money. But not only money, it will also will be more simple to handle the system. So now that I have drawn this, I have a nice map. We draw it on QGIS. I suggest to do a new concept, more simple, and also for irrigation. That's one of the big issue now, is we're losing quite a lot of water now for irrigation because we don't know really how much water we're giving and how much water the plot need. But if you map everything, you will know like, okay, for this plot I will need like 2.5 millimeter for each week for areca nuts, for example. So if I know this, I can do try to find a good irrigation system. So with a discussion with uncle, we decide to take some sprinklers. Sprinklers which will go all around. So it has a perimeter of irrigating of 20 meters. And so I plot for the whole crop how many of the sprinkler we need. And so the water will come from this pump, then go down. Here we have an automatic valve, so it's working with just a timer, and which say each Monday during 2 hours you will sprinkle all this crop, and then between 12 and 2 this one, and then and so on and so on. And so we have the main line here, and then all the subline with on each point we have the sprinkler. So, and this way, now we finished it, we have to make the a simulation to know the diameter needed. So the pressure would be enough at each endpoint, so at each sprinkler or at the consumer. So for this, I did first I map it here with QGIS, open source program, and then we use another program, EPANET, to calculate the hydraulic pressure with the head loss and everything. And once you have done this, you can know the minimum diameter needed and all the pipes you need. And you can draw everything and plan the material needed for the work. So we estimated now for this concept we'll need like more than 2000 meter pipes of 40 millimeters and more than 300 sprinklers for irrigating automatically the whole farm. And now that is done, the next part will be during monsoon to put this all on ground, to construct it. So that's it.
Thank you, Mark. This looks brilliant. So guys, we have... Alright, so what Marc and Armel have done here is have a beautiful map of this farm and with various attributes. So if you just zoom into these plots where it's been marked, we have the attributes table will tell us what all farming activities being done over here. So there is the different types of crops. We have areca nut, nutmeg, cacao, banana, all these things, and plus our irrigation system. And also this can give us the indications on how the soil is performing, what kind of pest is prevalent over there, and what kind of prevention for the pest we need to do or manuring we need to do. All this information could be gathered, could be put into this map and could be used it for better management of the farm. So I really think this is beneficial, and I would like to thank Marc and Armel for doing this. And it'd be nice to have this kind of mapping done for other farms around here as well. Thank you.